Hi, my name is Arjun Chaudhary. This is the Capstone project for Professor Goral for Tuesdays and Thursdays at 9 o'clock a.m. Alright, so let me show the capstone. Okay. First, I'll begin by going through the two designs that I came up with according to the feedback from my stakeholders. And then I'll show the design that I chose and I will demo it. Alright, so I interviewed 3 people and basically the 2 designs that I came up with. So design number 1, I assumed that Main Street will have heavier traffic, so its green light should be twice as long as side avenues. There should be an all red buffer state during transitions, so before the next street turns green, make sure both lights are red so traffic can clear up to avoid any accidents. And for my custom C equals 1 mode, I decided since Main Street has more traffic, it'll keep Main Street green while Side Avenue stays red, which will be like a priority mode in case like an ambulance needs to come through, for example. Alright? And each light will last at least 1 full clock cycle, and I'll show that in my simulation. And I wanted to prioritize predictability and safety. And this is the state definition table. So my first state, the all lights will be disabled. Then red will be in both directions before Side Avenue turns green. Then Main Street is red, Side Avenue is green. Main Street is red, Side Avenue is yellow. Then Main Street is green, Side Avenue is red. Main Street yellow, Side Avenue red, and then the rest of them. The one I wanted to point out is that I have another state to keep both lights red, and this one's before Main Street turns green, and this one's before Side Avenue. And this extra state is to keep Main Street on green for 2 clock cycles, because remember, that one has more traffic, so we want to prioritize that. Alright, and this is the state diagram. You can go through that. This is the state transition table, and basically showcasing what I showed earlier, basically this. And these are my calculations. And I decided to use a decoder so like each appropriate state will get mapped to like the signal it should light up. Alright, and for design number 2, the assumptions I made is that both streets should receive equal amounts of time for green light, so 1 clock cycle, so one street is not prioritized. And for when C equals 1, I decided to add a pedestrian light, and for simplicity, it'll turn on when both intersections are red. So it's just one light, just for simplicity. And this also has a safety buffer, so all lights will be red before the next one turns green. And every light transition has 1 clock cycle. And this is my state definition table. My state diagram, so my definition, the diagram, the transition table, my calculations. And same thing here, I used a decoder to map each state to the correct light it should turn on. But here I have a pedestrian light this time. Alright. Same thing here. Okay, so for determining which design to use, these are my criteria: ease of design, circuit size, ease of understanding, and features and functionality, as well as safety and realism. So I chose these criteria based on what my stakeholders thought, the people I interviewed, and also just in general what I think something you are designing should have, which is simplicity, size, and good features. And how I applied this design: so for ease of design, I decided design 1 is more simpler because it has a more straightforward state flow because there isn't a pedestrian light to complicate things. For circuit size, design 1 uses less logic gates, so yeah. And then for ease of understanding, I figure since design 1 is more intuitive, because it's basically representing like a basic urban intersection, and its operation modes are more simple compared to design 2. And for features and functionality, I decided to go with design 2 because of the pedestrian mode. But for safety and realism, I decided both designs are good, but I decided design 2 wins slightly because it has a pedestrian crossing mode. So based on my criteria in my weighting system, these are the numbers, and adding them up, design number 1 wins. So I decided to go with design number 1. Alright, now I'll actually show my design. So this is my design, and I'm gonna run it, and it'll show you all the different combinations and outputs and states. So the first one is both C1 and C0 are 0, so it's 0, 0, which means that it should just simulate regular traffic flow. So if I clock it, you'll see both lights start at red, and you can see here, or even here, the decoder lights up state 1, which means that Q2, Q1, Q0, it's at state 1, and the next state, you can see it's 0, 1, 0, which is state number 2. And that is the state where side avenue will turn green. So if I clock again, you can see that we're at state number 2. Alright, and the next state will be 0, 1, 1, state number 3. And this is when side avenue will become yellow. So now side avenue has become yellow. The next state, well, it's 1, 1, and 0, so which would be state number 6. And this is where it goes a little bit out of order, but it flows smoothly. So if I clock again, we are now at state 6. Both are red, and this is a different state from 1 because this is the state that's red before Main Street turns green. The one before was before side avenue, so I decided to split that into 2 different states, just to avoid any potential errors or complications. Okay, so now we are at state 6. What's the next state? So it's 1, 0, 0, which is state 4. So if I clock again, we are now at state 4. Main Street has turned green, side avenue is red. What's the next state? Well, 1, 1, 1, which is 7, I believe, right? 1, 1, 1. Yeah, so it's state 7. Now we are at state 7, which is Main Street is green, side avenue is red. Now notice if we clock again, oh, I forgot to show that. So notice how Main Street was green both times, I believe, right? So do that. Yeah. So now we are at state 4, which is green. And then, sorry, I forgot to tell you this. Notice when I clock again, state 7, this is green. Main Street has turned green for the second time. And this is what I was talking about, that Main Street's green lasts twice as long as side avenue's green because it uses 2 full clock cycles. Okay, next will be yellow, which is state 5, and then the next state will go 0, 0, 1. And notice that is back to the same red state before side avenue turns green. So we clock again, and then it's the same cycle. So it just loops through, clock again, notice it ran twice. And yeah, just keep on going. And yeah, alright. Next, I'll show state where the inputs is 1, 0, so C1 should be 1, reset, and if I clock now, this is the flashing mode. So basically, you go to, how I did this is I went to state 5, you can see in the decoder, or even here, like 1, 0, 1, which is 5. And now this time what happens is, since you want it to flash, the next state, notice it's 0, 0, 0. And that's the state where all lights are disabled. So basically it'll cycle through those states to basically imitate like a flashing signal. So if I clock again, nothing, then, and if I just keep on doing this, notice it just keeps flashing. Alright? Okay. Now let's go to, we did 1, 0, now let's do 0, 1. Okay, so let's reset this. Let's turn off clock reset. Now if I clock, this is the four-way stop. So notice we are at state 1, which was when both reds, before we go to side avenue turn screen. But now instead, this time, the next state is 0, 0, 0, which goes back, just nothing happens, and then it just cycles between the two. Alright. Cool. And the final state is 1, 1. And this state is now the custom state, where basically what I was doing, what I decided to do for this one is it basically prioritizes Main Street. So Main Street will stay green and side avenue is red. This is in case of something like an emergency where an ambulance needs to get through, because Main Street tends to be the busier street. So now if I clock, notice we're on state 4. What's the next state? State 4. So it just stays stuck there, and it'll stay there no matter what we do, unless obviously we reset. Okay. Alright, so those are all the potential input combinations, states, and outputs. You can see everything works perfectly as it should, which is awesome. And yeah, that is pretty much all. I don't believe there's anything else I needed to talk about. Yeah, thank you for watching.